Hi, this is Ramachandran again. In today's lecture, I'll be talking about two things. First, we'll be talking about a systematic approach to using modeling in exposure scenarios and specifically the life cycle of a particular product. And the next part of the lecture today, we'll be discussing an important concept called uncertainty analysis. So, in this first section, I'll briefly discuss a systematic approach to using modeling for assessing exposures through the life cycle of a product. This is essentially extending the modeling of exposures beyond the occupational scenario to consumer uses of a particular product. If we are looking at the entire life cycle of a given product, and we need to assess the exposures of human beings throughout its life cycle, then modeling is in fact the only viable approach. We cannot possibly be measuring exposures through sampling throughout the life cycle of a product. It would be much more complicated than modeling. So, can we develop an exposure scenario for every possible specific use of a particular product and all the ingredients that go into making that product? So we can imagine in this slide that there are the raw ingredients that go into making a particular chemical, and then the chemicals get mixed with other chemicals to make a particular product. And in this initial part of the process, the main exposures are in occupational settings. Once the product has been created, it moves through the commercial chain, and in that process, intermediate professionals get exposed to these chemicals. So, for example, if there is a particular, let's say, a paint product, the workers involved in producing that paint and the raw ingredients that go into making the paint, they get exposed to those, and eventually the paint gets to a warehouse or a store like Home Depot, so the people working there get exposed to it, and eventually it gets to person's home who has bought this particular can of paint and is using it in his or her house, and so they get exposed to it. And the same can be said for any kind of commercial product, whether it's plastics or whether it's automobiles or whether it's some kind of chemical. There is a chain of exposures right from production all the way through commercial consumer use and then eventually its disposal. So, how can we assess exposures for this broad application? And so, one approach, one strategy is to use a tiered approach. And before we get into that, we should see if we can cluster some of the different scenarios where exposures can occur. And so we are using very broad, very generalized scenarios that are applicable to many situations. Once we've defined our scenarios, we need to use a tiered approach. What we do here is in the first tier, we use very conservative default assumptions. They are very simple assumptions, and the exposure scenarios are very generic, and there is very limited differentiation between the situations. So these are similar to some of the rules of thumb that we have discussed earlier. So this is the first tier approach. The second tier after this is where we use more complicated assumptions and assessments. We use very specific values for the inputs, as we have discussed in the various models that we have discussed so far. And we do differentiate between similar situations in the second tier. So, in the first step of this modeling approach, we need to identify, explore, and structure the use of the model. We need to identify the operational conditions under which a particular process is creating a particular chemical or product. What are the risk management measures in effect? So, are the workers wearing particular mask, or is there a ventilation system, and what is the air exchange rate through this particular room? those are the sorts of information pieces that we would need here. And we also need to provide some justification for grouping certain scenarios into one big scenario. So in the first attempt, we would break down the entire life cycle up to its use in the commercial chain into four scenarios. So in the first step, we consider all of the production scenarios as equivalent. And we know this is a very gross simplification, and we have discussed in the past how in an industrial situation there are many similar exposure groups. We are essentially going to combine all of them into one exposure scenario called production. The second scenario would be where these different chemicals that were produced in the production step get formulated or essentially mixed into the product. The third scenario is where the product gets used in an industrial setting to make yet another product. For example, using a paint to paint a car. And in the fourth scenario, we would be saying what are the professional uses or manual uses of this particular product. And again, the example here we can think of is the paint that is being used in a residential setting. So what we have done is we have taken a product, and I'm giving you two examples here of paint uses. They're all the individual chemicals that go into the production of a particular paint product, and then the formulation of the paint product itself, and then its various industrial uses, and then its various professional uses and residential consumer uses. Now we move to the second step. Once we've identified the scenarios, we need to identify what are the core determinants of exposure in each one of these scenarios. So we need to know the various parameters that go into using the models that we have discussed. And here I'm using the term model in a broader sense, so it's not just the mathematical models that we have discussed, but also the rules of thumb that are very simplified but conservative approaches to estimating exposure. So we need to know what the substance is and the product determinant. So we need to know, for example, the vapor pressure of a chemical component in a product and the percentage of that component in the product. We need to understand the processes and tasks in the industrial setting. So what are the different tasks and their duration and frequency? What are the temperatures and pressures that are prevalent in the process that's occurring? We need to understand the general and local ventilation characteristics and other control measures that may be in effect. Third, we start using our first tier tools, and these can be the rules of thumb that we have discussed earlier, and they provide us very broad and conservative exposure assessments. So the chain on this slide shows that we need to understand the process and handling parameters and substance properties. We need to know the containment and ventilation processes that are in effect, the duration of tasks and the amount of contaminant being used. And finally, we end up with an exposure distribution. Where do models fit in assessing exposure scenarios? So again, we start off with defining the exposure scenario as we have just discussed, and we start off with a tier one exposure assessment, which is a broad and very conservative exposure assessment. And then we compare the exposure that has been assessed with an exposure limit. And if this conservative estimate is already less than the exposure limit, then we will deem the scenario as being safe and we'll stop our process at that point, and that becomes our final estimate. But if the initial tier one exposure assessment is much greater than the exposure limit, then we say, okay, let's get down to tier two, where we do a more sophisticated, more in-depth exposure assessment using some of the more complex models. either the well mixed room model or the near field, far field model, or any of its variations. And we then compare the exposure that has been estimated with the exposure limit and determine if it's safe or not. And we keep iterating this exposure assessment until we arrive at a final exposure scenario. So the final step of this scheme is to describe the final exposure scenario that is safe for all possible uses of this product. And this includes a description of the activities and processes that are considered safe for this product, the duration and frequency of use, adequate control of risk. The product specification and the concentration of the substance in the product needs to be specified. The physical form of the product needs to be specified. And we also need to specify the maximum amount of time or activity with adequate controls. And we also need to specify the operational conditions of the use of the product depending on the temperature and pressure, emission or release factors determined by technology, and ventilation parameters. So the idea is that we can specify all the conditions under which a particular product can be used completely safely, irrespective of whether you are a worker in the first part of the production of the product or a professional who's using it or a consumer who's using it towards the end of the product. So we need to keep the following things in mind when we use models to assess exposures in scenarios. We need to use a tiered approach, starting from the most conservative onto more and more complex and sophisticated models. We need to be aware of the assumptions that are built into each model, whether it's a well mixed room or a near field, far field model, or even the rules of thumb that we have discussed. And then finally, we need to assess the effects of uncertainties in model parameters.